Hello everyone, I am Dr. Rihanna Roux. I'm a lecturer at Applied Mathematics, and today I'm going to tell you a little bit more about the mathematical science program that Stellenbosch University offers. So one of the most wonderful things about the program of mathematical sciences is the fact that we had a wide variety of subjects that you can choose from. For example, we offer applied mathematics, biomathematics, computer science, financial mathematics, operations research, mathematical statistics, mathematics, which also includes abstract mathematics. Now, you might have heard some of these names, but I don't think you really know what all of these subjects entail. So let's tell you a little bit more about them. So in applied mathematics, we develop mathematical models and theories in order to solve real-world problems. For example, a few years ago, one of my colleagues developed a model which determines how the water temperature in a marina of the V&A waterfront will change as the air conditioning systems of the nearby buildings deposit their water into the marinas. This kind of studies can help to make decisions about whether a plan a company has is viable, environmentally friendly and viable. If we think about biomathematics, that is the study of mathematical models that has to do with biological systems. One example that immediately comes to mind is that of disease modeling and how it will spread through a population. And that is something that all of us are very aware of at this moment. Now, computer science is something that you might know, and they will have a separate video to tell you more about what computer science entails. In financial mathematics, we want to study the mathematics that has relevance to finances. And you will see a little bit later on, if we look at the type of jobs you can do, that many of our students are employed in the finance sector as well. In mathematical statistics, we are interested in the mathematical underpinnings of statistics. So it's not just the study of statistics, it's the mathematics of statistics. And in statistics, we are interested about how you interpret data. Then finally, maybe one of the things that you know the most of is mathematics. Now, in mathematics at university, we take it a little bit further, and we can say that mathematics is the study of absolute truth. So here at university, you will have, we look at the discoveries of pure mathematics through different eras. You can also see mathematics as the backbone to many sciences. A sub-subject of mathematics is that of abstract mathematics, where we study the foundations of mathematics. Now, all of these subjects are moved into different streams. And these streams are focused on main subjects and in specific subject combinations. This is to make the choice a little bit easier, because you can imagine that you can't focus on all of these subjects during your university career. Somewhere you have to make a choice, and these streams help you to do that. For each of these subjects, that consist of modules that you take throughout the different years of your undergraduate study. The specifics about these modules and subject choices for specific streams can be found in our science yearbook, which is available at one of the two links, the one English, the other Afrikaans, at the bottom of your screen. So two examples of streams in the mathematical sciences will be that of applied mathematics and abstract mathematics, the two that we chose. So in applied mathematics, we will combine the subject of applied mathematics with electives like mathematics, computer science, economics, and operations research. And what this means is that you have to take all possible applied mathematics subjects throughout the 3 years. That means 2 applied maths in your first year, 2 in your second year, and then 4 modules in your fourth year. But then the rest of your modules will comprise of other subjects in the science faculty. And when you move towards your final year, you have to choose one of these electives that's noted on the screen. If we think about abstract mathematics, you will see that it has a wider base of elective subjects that you can choose from. You will take mathematics as the main subject and abstract mathematics, and then with that you can pair either biochemistry, chemistry, physics, genetics, computer science, or applied mathematics. And you can see the stream of abstract mathematics is well suited for people who are interested in pursuing a career as a mathematics teacher. So if you are worried about all these choices you have to make, there's so many electives, and how do you know what you have to take in your third year as a second subject? Remember that when you start in your first year, you are going to slowly move into these choices. You have a broad base in your first year, which you can choose from, and you choose the things that you find interesting and that you want to learn more of. And as you grow through your university career, you are going to realize which subjects you like and which ones you want to focus on. And that will then help you to make the right decisions towards your third year. So now I'm pretty sure that one of the first questions that your parents ask you when we talk about mathematics and your peers, what do we do in university mathematics? I mean, we have done mathematics for so long in school. Isn't this all of it? Well, it's not. Mathematics is a well-studied research area, and there's so much more to mathematics than just doing school mathematics. And what are these things? So what is the difference between university mathematics and school mathematics? Well, if I think about school mathematics, I tend to think that it's all about solving problems. Not problems, getting answers, I want to say. So you want to find a function, evaluate a function at a certain value, calculate the root of something, manipulate a function in terms of factorizing. So you are learning mathematics. While at university, we are interested in some other things as well. We want you to understand the concepts, see how they logically follow from the one to the other one, and to structure your arguments in a logical way. There's a huge focus on the development of mathematics from first principles to see how do we know that this mathematics work. One of my colleagues says something that I really like about mathematics at university. He says in school, you are a learner of mathematics, where in university, you are a creator of mathematics. And from the first year already, you can start to create mathematics, not just solve equations or manipulate functions. The last thing that I want to mention is that of problem solving. We find that many of our students struggle to solve problems when they get to university. And this is quite evident in applied mathematics. So yes, we do solve problems in school, but it sometimes tend to be, for this problem, I follow this specific recipe. And you don't necessarily have to think whether you can do something different with it. Well, when we mention we want to solve problems at university level, we want you to go through the whole cycle. The first question would be, what is the problem? Sometimes we don't really know what's the problem when we are faced with a real world problem. What's the real mathematical essence of this problem? After that, we want to find models to solve this. So these are kind of like recipes, but it's not a one-to-one correlation. So you might not always use the same thing. So you have this whole bag full of methods, and you have to choose which ones you want to use. Now, after you find the right method, you have to evaluate it and to make sure that you're doing the right things. And then if it is not working, then try and solve it again, and you have this whole cycle. So I think problem solving is one of the things that we should focus on more, and that is also what you're going to do in your job one day. So now the big question. I think this is most likely the question I hear the most from people around me. When I decided to be a mathematician a long time ago, my parents also asked me, what on earth are you going to do with a degree in mathematical sciences? So when my third years ask me this every year, I go through the trouble of going to search for a job in mathematics, because I really don't know what is out there until you search for it. And the one thing that I can tell you is that employers are looking for the skills that we teach you at university. They are not looking specifically for someone with a degree in mathematics or in applied mathematics. If you look at the job descriptions, it will be quite wide and open. It will say, we are looking for someone with a degree in mathematics, applied mathematics, operations research, engineering. So it's wide. So that just tells me that if you are looking for or wondering what you should choose for your subjects. Remember to choose things that you can excel at, that you are passionate about. Because in the end, we are interested in your skills that develops, the way you think of problem solving. But to give you an idea, I'm going to showcase some of our past students that specifically studied this mathematical science program and where they are employed at this moment. Let's start with something that you know a lot about, the education sector. So I can see the education sector is two parts, one of higher education and then school education. In higher education, you can become an academic, and many people think that being an academic just means that you teach university students. But in fact, most of our time, but a lot of our time, we spend time in doing research and novel research in mathematics and applied mathematics and all these subjects while we're expanding the knowledge base that we currently have. Michael Hoefnagel is a lecturer at Stellenbosch University, and he did his undergraduate degree in mathematical sciences. Then a profession that needs no introduction is that of a teacher. Constance Botma is currently a teacher at Valenture Institute, and she has also finished her undergraduate degree in mathematical sciences. Now, moving away from the education sector, I'm going to showcase some other past students. So one of my favorite jobs of our students is that of Christo Rautenbach. He's a scientist. I always wanted to be a scientist, and it's wonderful to know that there's actually someone whose job description is scientist. He works at the National Institute of Water and Atmospheric Research in New Zealand, and he's an oceanographer. Mark Chimes is a programmer at Vastec. Vastec is a Stellenbosch-based company that focuses on telecommunication solutions. So you can see that even if you study mathematical sciences as a broader subject, you can be employable as a programmer. You don't have to study computer science to end up being a programmer at the end. The buzzword nowadays certainly must be data, and that is also why many of our students end up in a data scientist position. One of them are Jacqueline van Jaarsveld, and she is a data analyst at Chorus Software. Now, they focus, for example, on how you can make informed decisions when you look at data. If you think about a data scientist in general, they will use machine learning algorithms or models together with statistical and mathematical models to try and find patterns in data. But not only find the patterns, but also to make sense of the patterns so that you can make informed decisions about these patterns that you observe. Jacqueline specifically will look at personal data, maybe from an online profile, and then determine from that data which kind of ad she should aim at you. We all do like that, people, don't we? On the other side, we have people employed in the financial sector. Mokgabo Malosi is a junior credit risk analyst at Prodigy Finances. And what that normally entails would be that you look at a person's profile, and then from the data in their profile, you can make a decision of whether they are worthy of receiving credit from your company or whoever employs you. Mabali Chuolo is a quantitative analyst. She works at Nedbank. And what one of her jobs that she has to do is to determine how you will make financial investments from portfolios, and then they will use the data to make financial decisions about your profile in the bank. Finally, I highlight Danique Brink. She is the Chief Scientific Officer at ID Cognify. It's also a Stellenbosch-based company where she is a machine learning engineer. So what else can you do with a degree? So this is just a list to give you more of an idea. You can be a research and development engineer, a financial modeler, operations researcher, a supply chain analyst, a crypt analyst, and a game designer. I always put that one in because I think it would be really fun to be a game designer. Then at the bottom of the screen, you can see two websites that you can visit. The one is weuseMath.org, which is an international website that lists jobs for mathematicians. And then the other one is our South African Maths Foundation's website, where they showcase South Africans that studied mathematics and what they do in their careers. So thank you so much for your time. I always think that you have to, when you make a decision about what you want to study, you have to think about what's your passion. What do you really like? Because passion drives excellence. And if you want to be excellent in your career, you should like what you are doing. Thank you so much for your time.